Hello students, in this session we will be taking questions from application of derivatives. Application of derivatives has most number of questions in this sheet and some questions are quite tricky. They're slightly different from the board level questions. So before we begin with the questions, what we'll do is we'll quickly run through some important concepts which you might or you might not have come across. If you haven't come across them, you'll have to understand those concepts and make a note of those formulas and we'll be using them in the questions. So let us begin with some concepts. Now, the first concept which I want you to understand is one point which you might have come across in grade 11th. I'm sure you know what is odd function. You must have come across odd and even function. So I want you to understand what is odd function, and there's one property of odd function. Let's see if you already know this or not. The property is that odd function is always symmetrical about origin. So let's say if we have this function x cubed. First of all, how do we check whether it's odd function? So to check whether it's an odd function, we replace x with minus x. So this becomes minus x, the whole cube. This is negative of x cube, which is negative of f of x. So this is an odd function. If f of minus x is minus f of x, then that is odd function. If we have an odd function, that will be symmetrical about origin. If you check this graph, the function is x cube. This is the graph of x cube. On either side of origin, it is symmetrical. It's a mirror image about origin. And therefore, we say it is symmetrical about origin. So this is one point which you need to know. Now let's see what happens in case of even function. So if I take, let's say, x raised to 4. Now, first of all, the definition of even function, f of minus x is equal to f of x. We can check it for this. If we have f of x equal to x raised to 4, when you replace x with minus x, this is going to be negative of x the whole raised to 4, which is x raised to 4. So do you observe, students, that even function is that function where f of minus x is equal to f of x? If you look at the graph, it is clearly symmetrical about the y-axis. So for even function, you can remember that it is symmetrical about y-axis. Now, let us begin with the next concept, students. The next point that we have is the first derivative test. See, if you have done Maxima Minima, which is a part of application of derivatives, then you have definitely come across the second derivative test, where we take the first derivative, we equate it with 0, we generally get two values of x at times one value of x, and then we take the second derivative. In the second derivative, we substitute the values of x. At that particular value of x where the derivative is less than 0, it is maximum. Where it is greater than 0, it is minimum. I'm sure you have come across all of that. Now here, we are going to discuss the first derivative test. So this has never been asked in boards so far, but in this sheet, we could find one or two objectives based on the first derivative test. So it's better that we are prepared with it. So let's understand this. Now we'll understand this with the help of a graph. So in case of first derivative test, we have to first discuss that point that at x equal to c, where c is any number, in question we'll have numbers. If x is equal to c and if a function has a maximum at that point c, let's understand what happens. We'll understand this with the help of a graph. So on x-axis, let's consider this point c, such that at point c, this function has a maximum. Now, students, we know that maximum and minimum will always be at the critical point, which means the derivative has to be 0. So at c, definitely the derivative is 0. This is one thing. F dash c has to be 0. So here, the tangent at this point will be parallel to x-axis. The derivative will be 0. I'm sure you already know this. Now, what you have to understand is if it is an increase, if x equal to c is that point where it is maximum, look at the nature of this graph, students. Do you understand? To the left of c, let me just shade this for you. To the left of c, the graph is an increasing function to the left of c. And to the right of c, it is a decreasing function. So you have to understand, if it is increasing first, then decreasing, then definitely this point is the topmost point. It is the maximum point. Mathematically, how do we conclude this? Because we'll not be making graphs in question. So if this is increasing, if I take any point just before c, let's say this is c minus h, the difference is h, then at this point, students, do you understand the derivative has to be greater than 0? It will be greater than 0 because for increasing functions, I'm sure you know that it is greater than 0. So we'll conclude that at this point c minus h, f dash of c minus h will be greater than 0. And for other points c plus h, that is to the right of c, it has to be lesser than 0 because it is a decreasing function. So remember, students, if it is increasing first and then decreasing, that is if the derivative is positive first and then negative, then we can say it is maximum at that particular point. So when derivative changes from positive to negative, it is maximum. I hope you understood this. Now, similarly, we'll discuss minima. Now, students, it's very clear. In minima, this has to be the situation, which means it is first decreasing and then increasing. So here, if it is minimum at x equal to c, in that case, students, the point just before c, that is c minus h, at that point, the nature of the graph is decreasing. So f dash c minus h is negative. And f dash c plus h in this case is positive because it is increasing. So if the derivative changes from negative to positive, then it is minimum. So in questions, if you don't even learn this, by logic, what we will do is we'll check if it is increasing first, then decreasing, then this has to be the topmost point. If it is decreasing, then increasing, this has to be the bottommost point, the minimum. Chalo, we'll take one question so that we ace this type. We'll find the local maximum and minimum of this function. I'm sure students have done such questions with the double derivative test. I'm sure everyone is well versed with it. Now here, we're going to discuss this with first derivative test. So the first step is you take the derivative. Derivative of this function will be 3x squared minus 6x minus 24. Now we equate this with 0 and find the values of x. Over here, when you solve this, I'm not showing this in detail. I'm sure you can manage this. You'll get the two values of x as 4 and minus 2. Once you get the values of x, students, now comes the main part. You have to understand one of the points is going to be maxima, other is going to be minima. How to figure that out? For that, I'll make a rough number line. On this rough number line, I'm taking these two numbers, minus 2 and 4. Now, students will basically decide where is it positive, where is it negative. When I say where is it, I'm talking about derivative. Where is derivative positive, where is derivative negative? Now, to the left of minus 2, let me take any random number. I'll take minus 3. When you substitute minus 3 in this function, students, let's see what happens. We get 3 into minus 9. We get 3 into minus 3 the whole square, which is 3 into 9. So that's 27. I'll do the rough work here. So that's 27. Minus 6 into minus 3 is plus 18 minus 24. I'm not interested in the value, students, but I'm 100% sure it is positive in this part. Now, when you take between minus 2 and 4, generally, remember, generally it is positive, negative, positive, or negative, positive, negative. It's alternate. We'll still check. So between minus 2 and 4, I'll take 0. When you substitute 0, you'll get minus 24. So it's negative. When you take a number to the right of 4, students, let's take 5. It's 3 into 5 square, students, which is 3 into 25, 75. Minus 6 into 5, 30. So, and minus 24, that will be positive. You can work it out. This is positive. So now, students, the conclusion, they're saying that to the left of minus 2, at minus 2, students, it is first increasing. It's positive, then it's negative. Do you understand, students? At this point, it's going to be maxima. And here, students, it's decreasing first, and then it's increasing. So at this point, it's minima. And that is how we conclude maxima minima using the first derivative test. So we can say maxima is at x equal to minus 2, minima is at x equal to 4. If you want, you can work this out with the double derivative test also. Obviously, you'll get the same answer. I hope you understood the students. We'll proceed to the next concept that we need to revise. All right, students. So now the next point that we have, most science students, I'm sure, are well versed with this concept. But for commerce students, this might be a little new. So let's see if you already know this. So let's say we're basically discussing a part of physics, which is not really hardcore physics. It's got to do something with math as well. I'm sure you have come across terms like displacement, velocity, and acceleration, right? In grade 10th physics, you must have come across them. So let's say that displacement is a function in terms of s. So if displacement is a function, so let's say displacement is a function. So let's say displacement is a function given by s equal to f of t. Then velocity is found by taking the derivative of displacement. So it is derivative of displacement function with respect to t. And acceleration is found by taking the derivative of velocity. So do you understand? If it is derivative of velocity, it is double derivative of displacement. So it is derivative of velocity, which is double derivative of displacement. This is the very basic concept which we will be using. There's no physics formula which we'll be using. There are one or two questions where we'll use this concept, so you must be prepared for this. Other than the students, there are a few more terms which I'm sure you already know. We need to just go through them quickly. Derivative is 0 at those points. We say that if derivative is 0 at a particular point x, then that point x is a critical point. I'm sure you have come across this term already. That point is also called a stationary point. So if the derivative is 0, these are the terms which we will be using. And those points where the double derivative is 0 are called points of inflection. Points of inflection. If you don't know this, if you didn't know this earlier, you can make a note of this. For the students, the next point that you should know, I'm sure you have come across this either in grade 10th or in grade 11th. So let's consider an example. Let's say if we have this circle. On the boundary of circle, I'll mark 2 points. So I'll take this point A, I'll take this point B. When we join A and B, students, this is an arc AB. We're talking about the formula of length of arc. We generally denote it by S. So length of arc, S, is given by the formula R theta, where theta is in radian. Other than the students, there's one more formula which you need to know. Let's say if this is the center of the circle, if I join O with A, I join O with B, then this students is called a sector. So let's consider this angle theta. Area of sector is given by the formula half r square theta, where theta is again in radians. I hope you already knew this, student, from grade 11. If you didn't, you will have to learn this for one case study, for one 6 marker, which we'll be solving today. Other than the students, there's one formula from straight lines, grade 11 straight lines, which you should know for the tangent and normal part, angles between two lines. Let's see if you recall the formula. So if we have two lines, one has slope m1, other has slope m2, then this angle theta between them is given by the formula. Tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. This is the formula. There's one more concept which I want to discuss now. This is from grade 11th trigonometry. There's a question which you must have come across in grade 11. Let us see how to solve such questions and let's see if you recollect them. So let's say if I ask you to simplify something like root 3 cos alpha plus sine alpha. If I just ask you to simplify this and express this as a single trigonometry ratio. So in this case, students, the approach is slightly different, it's slightly special. Over here, students, do you understand? We have root 3. Now, root 3 is somehow related to sine and cos. Do you know that sine 60 is root 3 by 2 and cos 30 is root 3 by 2? So what we'll do is, students, we'll try to create root 3 by 2. Now, to create by 2, we'll multiply divide by 2. So I'll multiply by 2 and divide by 2. So we have root 3 by 2 cos alpha plus 1 by 2 sine alpha. Now, students, we can write root 3 by 2 as sine 60. This is cos alpha. Half is, students, cos 60. And this is sine alpha. And this is how we get, students, 2 times sine of 60 plus alpha. I hope, students, you recollect this. If not, I hope you at least understand this so that you can replicate it in similar questions. All right. So, students, that's it for this particular session. We have to now take questions. We'll take that in the next session. So you revise these concepts and I'll see you in the next video. We'll take questions from that sheet. Thank you.